So in this question, we've been asked to prove that tan theta plus cot theta is equivalent to 2 cosec 2 theta. So what we're going to do is we're going to work through this together and look at all the different stages we need and all the different trig formula that we need to be able to prove this. So we need to have a think about what terms we have and what we know about them and how we can rewrite them. So whenever we see a tan theta, we always know that a good way to rewrite this is going to be tan theta is equal to sine theta divided by cos theta. And then in terms of our second term here, we know that cot theta is going to be 1 over tan theta. So I'll just write this here as well. So we have that cot theta is equal to 1 divided by tan theta. But then we have just written that tan theta is equal to sine theta over cos theta. So then that means we can actually rewrite cot of theta in terms of sine and cos, but this time it's 1 over tan theta, so we flip this fraction here. So cot theta is actually equal to cos theta, and we divide that by sine theta. So our next step will be to take these new terms here and substitute them into kind of our original equation so we can make progress towards this proof. So we'll continue down with the equivalent lines. So we will just move over to the side slightly. So we'll have that tan theta plus cot theta is going to be equivalent to sine theta, and we divide that by cos theta. And then we are going to add on cos theta divided by sine theta. And then I think the next best step from here would be to make these into a single fraction. So to do that, we need to add them together. Sine squared theta plus cos squared theta. And we divide that all by sine theta cos theta. So we now have a single fraction which we can deal with. So our next thoughts are, what do we know about these terms? So the first thing that springs to mind is sine squared theta plus cos squared theta. So we know that we have we know the following trig identity, that sine squared theta plus cos squared theta is going to be equal to 1. So this is really good because 1 is a lot, it means the same thing, but it is a lot simpler to look at, and it is in the direction we want to go. So therefore it's great that we'll now be able to substitute 1 into our equation. We also take a look and we think sine theta cos theta. How does that look familiar? So you may think of the double angle formula, but the double angle formula, as you'll remember, is written as follows. Sine 2 theta is equal to 2 sine theta cos theta. You can see this is good. This looks similar to what we have. We have sine theta cos theta, and here there is sine theta cos theta. But unfortunately, the double angle formula has a 2 in front of it. So we now think, what can we do to manipulate this to get it into the form we require? So what we can do is we can divide by 2. So if we divide both by 2, that's the same as multiplying by half. And then we see here that 2 will go and that will go, which that means that a half sine 2 theta is equal to sine theta cos theta. And that's exactly what we have here. So this means that we can continue with our replacement into the expression we have. So we'll then have 1 as our numerator, and our denominator is now going to be this here, 1/2 of sine 2 theta. 1/2 of sine 2 theta. So we know that dividing by a half is going to be the same as multiplying by 2. So this is going to be equivalent to 2 divided by sine 2 theta. And then finally, we'll go back and have a look at the aim of the question. So we were looking to write it in terms of cosec 2 theta, and we now have 2 over sine 2 theta. So we need to think, what other trig formula do we know that will take us to the next stage? So we do know that cosec 2 of theta is equivalent to 1 over sine 2 theta. And this is exactly what we need. We can now substitute this in, and we'll have that is equivalent to 2 cosec 2 theta. And then we'll just double check what we were looking for again. So here we can see in the question 2 cosec 2 theta, and we have 2 cosec 2 theta. So then we can just write a concluding statement such that tan of theta plus cot of theta is going to be equivalent to 2 cosec 2 theta as required. So now we've completed the proof. So we will now move on to part B of this question. We are asked to explain why the equation tan theta plus cot theta equal to 1 does not have any real solutions. So we recall from question 1 that tan theta plus cot theta is going to be equivalent to 2 cosec 2 of theta. And we recall, going back one step previously, that this was equivalent to 2 divided by sine 2 theta. And we're being told that this is going to be equal to 1. So what we now need to do is we need to rearrange this here and then have a look and see why there may not be any real solutions. So we can multiply both sides by sine 2 theta, which will give us that sine 2 theta is equal to 2. So now we're thinking, right, this is great. So we can then work out 2 theta is equal to sine minus 1 of 2. But we have a problem. We can't do this because no solution exists. So we need to think, why does no solution exist? So I've drawn some axes here. So let me now sketch out what sine of 2 theta may look like. So very roughly, it'll take this sort of shape. And we know that sine has a magnitude of 1 and then negative 1 on the lower y-axis. But our issue here is that 2 is greater than 1. So we know that sine is only going to be defined for negative 1 greater than or equal to sine 2 theta greater than or equal to 1. But we're looking for it being equal to 2. But we know this will never happen because 2 is greater than 1. So since 2 is greater than 1, the 2 is out with the range of the sine 2 theta. So this means that no solution exists. So we've now completed the question, and we're now going to take a look back to see where we picked up our marks. So looking back at question part A, it was worth 4 marks. So we received our first mark for going from the original equation down to this step here. So when we knew that tan theta was equal to sine theta over cos theta, and we knew that cot theta was equal to cos theta over sine theta. That's where we achieved our first mark. We then received our second mark for multiplying out our fraction and making it into one single fraction here. We then received our third mark for knowing that sine squared theta plus cos squared theta was equal to 1, and also using the double angle formula here. So we achieved our third mark at this stage here, and we then achieved our fourth mark for knowing that cosec 2 theta was equal to 1 over sine 2 theta, which then led us on to the correct answer where we picked up our fourth mark. Now for question B, it was worth 1 mark. And we achieved this mark for coming to the conclusion that sine 2 theta only runs between 1 and -1, and therefore no solution exists.